Okie dokie. So we didn't have any homework for today, but we're going to kind of pick up where we left off from last class. And I mentioned I was going to show you some ways of doing the whole vowel thing little bit fancier that'll kind of lead us into our assignment for Tuesday, where we're going to convert a decimal number into a hexadecimal number. So, that stuff we learned at the beginning to do by hand, you're going to now write a program that does that. Today we're going to cover some tricks with strings, let's say, and then we're going to also introduce functions. And we're going to kind of see it by we're going to take probably our remove vowels question from last class, and we'll probably move that into some functions and kind of see the purpose of what functions can do for us. And it's related to the question he brought up last class about, is everything always going to go in main? Or and I kind of mentioned that main ends up acting kind of like the quarterback. So main ends up being almost like just a bulleted list of the things your program does, where it's just deviating to other aspects, other areas of the program to accomplish stuff. So let's start looking at that. So let's see. For starters, let's just get it into a function as a beginning point. So we're going to say functions. So a function is a reusable chunk of code that we write generically one time and then can call multiple times with different inputs. All right, we'll see this by an example. All right, so syntax for a function. It's going to be return type, followed by function name, followed by opening parenthesis, followed by a parameter list. Oh, so it's call this param type. Param name, comma, dot, dot, dot. You can have 0 or more of those if you want. Opening curly brace. Then your logic will go inside there. All right. So let's kind of see this in reality as expanding this out. So I'll go into our code here. And let me just go ahead and gut this. All right. Now, for starters, what I'm going to do is I'm going to go ahead and write a function down here that just takes in a value and displays it. Let's write a very simple function. Okay. Now, I want to create a little slide here. Call this guy special note. So pay attention to this one because this is a commonly misunderstood aspect for beginning programmers. So I'll say it out loud first. There is a difference between a function returning a value and a function displaying a value. When we print something to the screen, that is for whoever's running your program's eyes only. Now, if we want our function to do something and then hand that result back to main or whatever part of the program called that, that is returning a value. It's not necessarily displayed on the screen at that point in time. You could display it, but those are two different things. Now, when I ask you, so for instance, let's say on the midterm, I give you a question that involves, I might say, write a function that takes in this, two numbers and returns the larger of the two numbers. Let's say I ask that question. All right. As opposed to write a function that takes in two numbers and displays the larger of those two numbers. Let's write both of those and kind of see it as an example. All right. So we're going to write a function here. The first one, so let's say write a function that takes two numbers and returns the larger of the two. Now I mentioned in the notes we just wrote that we write functions generically. Nothing is hard-coded in a function. We write it to operate on whatever parameters were passed in. So that means if we call it with different inputs, it will give us different outputs potentially. All right. This is similar to the concept we've been talking about where I've mentioned, well, I say we have a string called S. And I say, well, how many characters are in S? S.length, number of characters. Because we don't necessarily know what string is contained in S. Even if we wrote it from a generic perspective, the way we refer to the number of characters that are in a string is by saying the name of the string dot length. That will return for us whatever the number of characters is. Okay, so we want to deal with things. You want to start thinking about things generically like that. So rule of thumb would be if you're writing a function and you find yourself hard coding things, probably doing it wrong. You want to assume that you're getting values from somewhere and you don't necessarily know what the variables contain. You just know what types of values they are. And you know what they're meant to hold. Like for instance, in this case, we're passing in two numbers. So we know we have two integers and they hold numbers that we're going to compare to each other and return the larger of the two. All right. We don't know what those numbers are. So we're going to ask our questions generically. All right. So this guy, since we're going to be returning the larger of two integers, our return type would be int. That's what we're going to be returning is an integer. Well, maybe we call our function find larger. Okay. Function names are kind of like variable names. Typically, they might start with a lowercase letter and then, it kind of spells out what they do using what this is called camel case. But, you can name your functions whatever you want, but probably make them meaningful names. This guy is going to take in two integers, an int a and an int b. In this case, you could have called it int num1 and int num2. These are just variables, so however you define them up here in the parameter list, that's how you have to refer to them inside the function. All right. All right, so now if I have two numbers and I want to return the larger of the two, I have to ask a question, right? So I'm going to ask the question, if A is greater than B, I'll return A. Let me check this up a little bit here. Else, return B. Now, in this case, if A is larger than B, we know A is the bigger number. If A is not the bigger number, it's possible they're the same number, in which case it doesn't matter which of the two we return. So that's why we just say else, return B. B was either the bigger number or it happened to be the same value as A and we're just returning it anyways. All right. Now, since we advertised up here that we will be returning an integer, we must have a way of getting to a return value in our code. Okay, it's not allowed to not return a value. Now, the interesting thing is that older languages like C and C++ do not do a great job of policing this. So we've seen some other weird behaviors from C and C++. If we were writing this in Java, and for example, if we took that else clause out, and all I had was an if statement like that, if A is greater than B, return A. This particular function only sometimes returns a value, right? It only returns a value in this case if A is larger than B. Under every other circumstance, it's not going to do anything. In a newer language like Java or C#, it would definitely scream at you saying, this function must return a value and not all paths in this function lead to a returned value. All right. In an older language like C++, it's going to depend on which version of the compiler you're using over the decades. Some will be more policing than others. I'm not sure what we're dealing with here, but the bottom line is that good programming practice would be if you're advertising a function that returns a value, it should return a value. Okay? So this guy's called find larger. It takes in two numbers. We don't know what values are in those numbers. We're writing this generically. We just know they're both integers. We're going to ask some questions about those integers. If A is bigger than B, return A. Otherwise, return B. We've advertised that this guy returns an integer. Okay. So I'm going to go ahead and run this program right now. I got no input or no output. Why? Why didn't this program do anything? All programs begin and end with main, right? My main looks very sparse in this particular case. What I've written here is an ability. This function has the potential for me to call it, passing it two numbers and getting back the larger of those two numbers. But I'm not using that ability currently. Okay? So now let's go ahead and call that ability from main. So notice here that my function is defined outside of the opening and closing curly braces in main. You could put it before main, but I'm purposely putting it after main. I'm hoping it screams at me here in a second, but if it doesn't, I'll explain the situation again. Again, we're at the mercy of the version of the compiler they're using. All right, so I'm going to go ahead and call this. Now, find larger is going to give me a value back. So maybe I call that guy answer. And I set answer equal to find larger, and maybe let's pass it 5 and 7. Now, which value is larger between 5 and 7? We all got that one covered before you took coding 1? 7's the bigger number. So we expect that when all is said and done here, answer will hold the value 7. Right? All right. So what's the output of this program going to be if I run it right now? All right, good. Gave me the error that I wanted it to be. But for a second, let's pretend it didn't give me that error. It would not have given me any output. Why? All programs begin and end with main. I called my function. I stored the result it gave me, but I did nothing with that result. I didn't display it. I didn't do anything with it. It did all the, well, in this case, it didn't quite get to the logic for a reason I'll explain in a second, but presumably it did all the logic, got the answer, and then I chose not to do anything with that answer, at the very least, to do anything with it that displayed it to the screen. All I did is store it and then let the program end. Sort of kind of wasted my time in the current case. But let's look at this error message. I mentioned a minute ago that I purposely put this function below main. Now, if we were writing this in a more modern language like Java or C#, this would have worked just fine. There would have been no error here. This goes back to something, let's see, special note. What was I know I said it out loud, but what was I trying to say here?
Didn't you say there's two different types of like functions where one?
Oh, yeah, thank you. So there is a difference between returning a value and displaying a value. And the reason I emphasize that is it'll be common on, for instance, a midterm, that I might say, write a function that does something and returns a value. I might also say, write a function that does something and displays the result. All right. Make sure that you're able to look at that and understand what I'm asking you to do. Those are two separate things. One of them would be a function that doesn't actually return a value, and I'll show you how we can write that, because we still have to have a return type. We would use a return type called void, which means nothingness. But if I'm just asking you to display something, you pass the parameters in, the function does its magic, and then you spit the answer out to the screen. As opposed to returning something where you have a function, it does its magic. It could choose to display it if that was part of what you wanted to do, but then ultimately it spits it out to whoever called that function. So it has that value to use in another part of your program. All right, we'll see examples of that today. All right, so let's put a little slide in here called compiler history. Now, we already know about compilers and that, compilers convert high-level languages into low-level languages, right? They're our power tool that we're using to be able to write stuff in a high-level language like C, C++, Java, C#, and ultimately get it down to that assembly language and ultimately zeros and ones that the computer understands so that we don't have to write zeros and ones. All right? So in the early days of compilers, they did a single pass on the code. Modernly, they do 2 passes on the code. I'll explain what this means through here. So because we're getting this error, the error says find larger was not declared in this scope. We've seen an error similar to that before, right? When we were looking at like our variables that we defined inside of a for loop, right? Like for int I equals something. And then after the for loop was done, we tried to use I and it would yell at us and say, hey, we've never heard of that guy because I was born as part of the for loop and died when that loop was over, right? All right. This is the same thing. It's saying, hey, all programs begin and end with main. So it started up here in main and it sees me trying to call find larger. It says, I've never heard of this guy. All right. So now one thing you could do, I'm going to say this isn't the right thing to do. We can just move that before main. Now it's not screaming at us. Okay. Now, a single pass compiler, which this compiler, I would say, good for this class, is the older style single pass compiler, which is what C++ originally had. It's just going to go from the top of your file towards the bottom of your file as it reads in tokens. So when I had the function below here, it never actually got down to this part of it before it was compiling this code. Which means by the time it got to this line, and I'm referencing this thing called find larger, it's never heard of it. We know it's going to eventually run into it because we defined it down here. Remember, this is still compile time. This is before we've actually run the program. This is the compiler going through and making sure that what we wrote is at least syntactically correct. So it's yelling at us and saying, look, you're calling something here that isn't built into the language. And as far as I'm concerned, I've never heard about it at this point. Even though we look at it and say, well, I defined it right here. This was a newer language, or it was a version of C++ that used the 2-pass compiler. What it would have done is it would have gone through one time, reading in all the various tokens we defined. Then it would have made the second pass. And when it got to this, it would have heard of it because it would have read it in later on in the program. Okay. But in this case, we're dealing with a single pass compiler. And when it got to this line, from a compiling perspective, it's going to say, you are calling something I've never heard of. And it's going to scream at us. Now, I just showed you that we could fix this problem by moving that function above. And you might say, oh, well, that's good enough. We'll just move it above and it'll stop screaming at us. But that actually has more problems. Imagine that before we get to main, we have 10 different functions up above. And let's say some of those functions call each other. You might run into a chicken or the egg problem where this function refers to a function after it, and this function refers to a function before it, and these guys haven't heard of each other by the time you're compiling them. And there's no way around it. Okay? So the appropriate way of doing this. So I would make the argument that good programming practice would always have you define your functions after main. And then what you would do is just copy this very first line here of your function. And we'll put that above main. These are called function prototypes. So now what we've done is we've given the function header. By the way, pretty soon we're going to be looking at header files. that are going to kind of move this into having multiple files, which you also asked last class. But we're not quite there yet. But this is giving the function header. So this lets the single pass C++ compiler know that there will be something called find larger that takes in two integers. And actually, you wouldn't even need to put the int A and int B here. You're just saying it's called find larger, takes two integers, and returns an int. But if I were writing this, I always just copy my header from down here and paste it there. Why change it? All right. So we're saying, look, there's going to be a dude in this program called that. So for compiling reasons, I'm letting you know ahead of time about this guy. I haven't implemented it yet. So the logic for that guy still gets written down below. I'm just letting him know he's going to exist. So as the compiler makes its single pass, he's going to run through here and say, oh, okay, I'm going to go ahead and add to my list of tokens that there's a dude called find larger that takes two integers and returns an int. It's going to remember that. So that when it gets to this line right here, it's going to know what we're talking about. It will have heard of it by then. All right, so if we go ahead and run this now, it's happy again. Okay, makes some sense? So these would be the function prototypes, which you will always have before main. That way, everything that's going to exist that you might call from main or you might call from within any of those guys has been listed out up top. But none of them are implemented. That way we don't run into that chicken or the egg problem I referenced, right? Where you have two functions that you wrote that rely on each other and you have no way of defining them before each other. So now you're just saying, I promise all this stuff will exist. I'll implement it later. That's what we use these prototypes for. All right. So now I run my program. It doesn't scream at me anymore because when it gets to this line, it has heard of that token. And when it finally gets to this, it reads in the logic for that guy and compiles that. So then when it goes and runs it, it can trust that when it gets to hit this, it has logic that it can execute. All right, so I run my program here and we see nothing happens. Why? Well, just like I mentioned before, I'm calling my function. I'm passing it two integers. 5 is coming in for A. 7 is coming in for B. This guy is going to do his logic. If A is greater than B, return A. Otherwise, return B. That value is going to come firing out of the back of this function, and we're catching it inside this variable called answer. So I'm remembering the answer that's coming from that function, but I'm not doing anything with it. So now I can do like a cout answer and L, and we expect 7 to be the larger of the two values, right? So now we'll run it, and we see our 7 right here. Now, because functions are generic chunks of code, reusable chunks of code that we write one time, but can call multiple times with different inputs, I can then do something like cout find larger 13, and we'll do 13 in there just to show the two values. So I'm calling my function again, but in this case, I'm actually never storing the result. I'm just displaying it directly. All right, but we see that we wrote our function one time, we wrote it generically, and now we're calling it with different inputs. I'm calling it once with a 5 and a 7. I'm calling it again with a 13 and a 13. 13 and 13 is going to come in, so 13 will come in for A. The other 13 will come in for B. Is 13 greater than 13? It is not. So it's not going to return A. Instead, it's going to return B, which also happens to be 13. So that'll be the number we get from that. So we run this and we get our 13. But keep in mind that the first time I called find larger, I stored the result. I remembered the answer. I displayed it up here, but I can come down here and display it again if I want. So even though I've called find larger again, passing it new inputs, I have already remembered the result from my first call to find larger. So this will print out a 7 followed by a 13 followed by a 7. All right, that makes some sense. All right. Now,
Hang on.
but
What does why do we print 13 twice in the find larger?
why did we print 13?
In the see out find larger 13, 13. Why is 13 there twice?
Oh, because I just passed this 13, the one I have highlighted is coming in from my input A. The second 13 that I have highlighted is coming in from my input B. These are just different values. I can put 288 in there if I wanted to. Remember, our functions are generic. It takes two integers. I can pass it any two integers I want. And it's going to take the first one in as my variable called A, the second one in as my variable called B, and then the logic in here presumably is going to use those two values to do something. In this case, it compares them to each other and returns the larger of the two values, or in the case they're the same, it'll just return one of the values. In this case, it returns B. So I was testing it here by just giving it the same number twice just to show that it will give us the correct answer from that guy. But obviously, if I do 288 and 12, now it's going to display a 288 there as my second value, because that was the larger of those two values. All right, so now I'm going to write another function. This is going to be related to that special note where I might want to display the larger of two values. So that guy's going to have a return type of void. Void means I'm not going to return a value. Don't expect me to return a value. We're going to call this guy display larger. You could call it whatever you want, but that's roughly what this guy's going to do. We'll have it take in two numbers. They don't have to be called A and B. You can say int num1, comma int num2. You can say int LOL, comma int elephant, whatever you want, but probably make them meaningful variables, or in this case, it's just two values and neither one of them have any real meaning to them other than they're just integers. So display larger is going to have the same logic as we had down here. I'll go ahead and copy that logic. But we're no longer returning values. Now what we're doing is we're displaying values. So we'll say cout A. Down here, we'll say cout B. Then up here, we can say display larger, passing it a 21 and a 52, for example. And what's our output of this program going to be? Well, which is larger, 21 or 52? 52. But this guy's going to be an error. Why is it going to be an error? Never heard of this dude, right? So we got to make sure we prototype it. Implement your functions below main, prototype them before main. To prototype it, just copy the first line of your function and then paste it before main and put a semicolon after it. We're just creating a list of things to come. All right. So now when I run this, we get our 52. Okay, but notice I am not outputting that value right here. Instead, my display larger, it does all the outputting inside of there. It never returns a value. What happens if I try to return this value? So the operator, so the cout, cannot be applied to things that are void. Like, look, I don't know what you were expecting of me, but I don't know how to print nothingness. Make sense? All right, so that's why the cout here doesn't make any sense. Instead, our output in this case, just because we made up the idea that we want to display some values, the larger of two values, the output is inside of this guy. Now we could actually do both and. we could have display larger, return an int, and internally it would display a value, and then it could return the value afterwards. It could display a value, it could return the value afterwards. And then up here, we could do now cout that guy, and it would work. We do need to make sure we remember to update our prototype to no longer be void. Now it's an int. So now display larger is going to take in a 21 and a 52. It's going to go through this logic. It'll print out the 52, but then it's also going to return that 52. And what am I doing with the value it returns? I'm going to display that. So it's going to actually show me 52 twice. Once from within the function, once after the function. There's my 52 twice. The second one was this line displaying what this guy returned. The first one was inside that function when we outputted the 52 right there. Make some sense? All right. I'm going to go ahead and move that return statement, return B, before the cout. And now what we're going to see is we actually only get a single 52. And that 52 we got actually was this guy right here. One where we couted the final value. We never made it to this line. And that has to do with this return keyword. So let's add this to our notes. Return keyword. Up to this point, you might assume that the return keyword is what we use to always return a value from a function. The reality is that the return keyword could return a value if we wanted to, but the real function of return is return makes a function immediately end. So no additional lines in that function will execute. So when we said return B, we killed the function. We got the value out of it. We returned that 52. And then we printed it out back in main, but we never got to the line inside the function where we outputted the 52 inside the function because we killed the function the line before. All right. Now, that's an important consequence of the return keyword, because that means that if we're ever in a function and we've gone as far as we can go and we want to have a convenient way of bailing out, we're like, okay, we've already done our logic. I can keep checking stuff. I know I'll never find anything else. We can just put a return with a semicolon and the function will just end. So you can use return statements inside of void functions, as long as you don't return a value. You just say return, which is effectively saying function die. All right, that makes some sense? So that's something to kind of put in your back pocket, because there's going to be plenty of situations when you have a function that's doing some stuff. And once you have your solution, even if you're not done moving through a collection of stuff, all right, you might say, okay, well, I found the answer I'm looking for. I don't need to check the rest of this stuff. Yet we're in the middle of a loop, let's say, and you want your function to just end. I don't want it to spin through another 30 times in my loop, checking for something that's a waste of time. So you can just say return, function will end. You'll get your response. So in that case, you'd say return whatever your response is if you were returning that value. Or if you wanted to display the value, you could display it there and then just say return and the function will end. But at that point, you're no longer going to have to keep looping through the loop. All right. Now I'll introduce two other related kind of keywords here, since I'm kind of mentioning loops here. All right. So let's call these guys loop breakers. Let's see. Let's call this loop keywords. So we really have two keywords here. One is called break The other one's called continue. Break immediately ends the loop and continues the program immediately following the loop. So in a similar example to what I just explained, let's say we have a loop that's going through a collection of stuff, maybe every character in a string. It finds what it's looking for, but there's still 10 more buckets in the string that it's going to flip through if for as a waste of time. We could say, look, I found what I want. I want to now continue on with the logic that's after the loop. You can just throw a break in there and it will just bail out of the loop. Make some sense? So that's another tool that you now have in your tool belt that if you need to ever break out of a loop early and pick up where the right after the loop, you can say break. So it's just break semicolon. And we'll see examples of that. Similarly, with continue. Sometimes you'll be in the middle of a loop and for whatever reason, depending on the problem you're trying to solve, you decide, okay, well, this particular pass through the loop is a waste of time. But I'm not done looping. I just don't really have anything to do with the loop with this value, this part of the collection, let's say. So you want to skip the rest of the logic that's inside that loop, and you instead want to circle back up and move on to the next value in the loop. So continue skips the remainder of the lines in a loop and continues on from the beginning of the loop with the next value. So this guy would be something that doesn't actually get you out of the loop, but just lets you skip this particular pass through the loop. You may never use it. Well, you probably will use it at some point, but another tool in your toolbox that you can use. So we have two ways specifically for working with loops. We can break out of a loop altogether, but stay within a function in our current example. Or we can continue, which is just skipping this particular iteration through the loop and moving on to the next iteration. Or we can end a function altogether with a return statement. All right, questions about that? Go ahead. Okay, well, so remember in this slide here where we defined our syntax for writing a function? The syntax for a function, this is generic syntax. The first thing that we write is whatever kind of value we're returning. This is the type of value we expect this loop to spit out when it's done. So if we expect it to spit out a number, like an integer, we put int. We'd advertise it's going to return an int. But if we don't expect it to return anything, maybe we're just printing some stuff in there, or in a later program, maybe you're just talking to a database somewhere and updating something, saving a value, whatever, but you're not actually spitting any value out from your function, then you still have to advertise what kind of value this is returning. So in an event when you're not going to actually return a value, you would advertise void. I'm not going to give you anything. Okay, so, but you always will have a return type for every function. So the return type would be the kind of value that function will spit out, or void if you don't intend to spit a value out. Char, double, string. And as we start inventing new objects, you could put anything you can create a variable of. Okay. All right. So we have some examples of a couple of functions, and we have at least a rough beginning idea of the general syntax for a function. Return type, name, list of parameters. Now, you don't have to have anything in that list of parameters. I can have a function, let's just say void do something. That could be my whole function. I'm not going to return anything. The name of the functions do something, and I don't need any inputs to work. Now, remember, how do you figure out what inputs you're going to need? So in this case, we name the function display larger. Our intention is to display the larger of the two values that were given to us. If I didn't give you any inputs, if I did that, display larger, what am I expecting you to compare? You don't have the values, right? So the parameters are the inputs that are going to be required by your function in order to do its job. So in this case, I want to display the larger of two values. So I'm going to have to give you two values. Make sense? And if you want the user to give you two values, you got to tell them that you expect two values. Just like the return type, you say, what kind of value am I expecting return? You also have to say, what kind of values do I need you to hand me in order for me to do my job? All right. So one thing that you'll want to practice initially is when somebody asks you to write a function, start with focusing on that header. The very first, don't even get into the logic yet. Just the header is, what kind of value am I returning? What's the name of my function? What inputs do I need in order to do my job? Make sense? You get used to doing that and it'll become second nature. But what's common among beginning programmers is they might write their display larger like this. And then the very first line, they do something like A is equal to 7, B is equal to 4, something like that. At that point, it does not matter what the user ever passed to this function. It doesn't matter what A and B used to be. It's now 7 and 4. You've changed it. Okay, so now you have a function that no longer operates generically. It operates on 7 and 4 every single time, regardless of what you pass it. So if you find yourself, if you ever find yourself overwriting, hard coding the values of your parameters at the beginning of your function, red flag should be going up. You're doing it wrong. Parameters are meant to be generic for a reason. This allows us to have reusable chunks of code that we can pass different values to, and it can perform the same logic on those different inputs. Okay? So something like this would pretty rarely be a thing. Now, maybe, let's say that you had a function that required that it gives you a value of at least 0. And if they give you a negative number, you want to treat it as if it was 0. You could then do something like, well, if A is less than 0, go ahead and set A equal to 0. Something like that. You are situationally modifying your input so that it's compatible with your logic. Okay, but you're only doing that if the person who called your function gave it a incompatible number. You're moving it back to compatible. Or you might decide like, look, you gave me a compatible number. I'm going to give you an error. I'm going to scream at you, and then I'm going to return because I can't work with what you gave me. All right. If you're at a restaurant, you try to pay your bill with a Home Depot gift card, probably going to hand it back to you. All right. That's not a compatible input for their cash register or their point of sale system, whatever. And hopefully what you're seeing is that as I keep harping on so many of these things, I'm always connecting it back to real life examples. Because remember, as human beings, we are problem solvers. We're solving the same kind of problems we might solve in real life. If I handed you 2 note cards with numbers written on it, and I told you to hand me back the one that had the bigger number on it, every one of you could do that, right? When I ask you to write the code to do that, it becomes a little bit more sketch, right? Because you're not experienced at expressing that in C++ syntax. But you already know how to solve that problem. So the very first, and I mentioned this in the last class, that a common mistake that beginning programmers make is they see a question and they immediately start writing code without ever asking themselves, well, what problem am I actually solving first? And then what's the next problem? And then what's the next problem? You know, you got 11 lines of code with 50 extra curly braces written before you even ask yourself, what am I trying to do here? So you're practicing on that process of solving problems. As human beings, you've been solving problems since you were born. Okay, so these things have come as second nature. So even if I hand each of you 2 cards with numbers written on them, I say, hand me back the one with the larger value, even though it seems like you're not putting any thought into it, you actually are. You are. You know, somewhere in your brain, you're glancing at those 2 numbers and you're saying, well, this one's bigger, right? All that stuff is happening. You're just so good at solving those problems that you have trouble articulating how you're solving it because you just do it. Make some sense? That goes back to class number 1, when I said, why is programming difficult? It's because human beings are so good at solving problems, they have a hard time about articulating how they're solving it. And to program to tell this dude what to do, we have to articulate how to solve it. All right? So let's write some other stuff here related to the previous assignment. Let's say that I want to write a function that returns a Boolean. Maybe it's called isVal. It takes a character as a parameter. And I want this guy to return true if the character I passed it was a val and false otherwise. All right, that's something we used in the last homework assignment, right? We wanted to be able to identify vowels in the last homework assignment. So I prototyped it right there. So we'll go ahead and implement it after main. We have a variable named C. I want to return true if C is a val. So you could write your monolithic if statement here where you say, if C is equal to an A, return true. Else if C is equal to an E, return true, yada, yada, yada. Or you can just say return C equivalent to an A, or C equivalent to an E, or C equivalent to an I, or C equivalent to an O, or C equivalent to a U, or just going to steal all those guys. I'll kick it down the line here. And I'll make it the uppercase version of all those. Oh, sorry. I didn't quite copy enough. E, I, O, U. So if any of these Boolean expressions are true, because we're separating them by ors, if any of them are true, if C is an A or an E or an I or an O or a U or a capital A or a capital E or a capital I or a capital O or a capital U, this will boil down to true, a single value of true or false. Remember when we talked about Boolean expressions? Is there any expression that boils down to a single value of true or false? And I said it doesn't matter how complex or scary a Boolean expression looks like. If it boils down to a single value of true or false, it's a Boolean expression. So this is a pretty involved one with a whole bunch of ors in there, right? But it still boils down to a single value of true or false. This will return true if any one of these things is true. And if none of those things are true, it'll return false. So now, I'll just use that up in main. Because right now, I've written all these functions, but if I run my program right now, it's not going to do anything. All programs begin and end with main, and main does nothing right now. Even though I have all this logic written. All right, so let's do cout isVal, pass it an A. That should be a true, right? C out is val, pass it a B. That should be false. So there's our true and our false. So effectively what we just wrote right here is a little tool that allows us to detect vowels, right? And I think in the last assignment, what were we supposed to do? Spin through a string and remove all the vowels from it? Only show the things that were not vowels? Is that accurate? Is that what it was? All right. So now let's use this new tool to do that. So let's give ourselves a string s is equal to hello. We'll create a for loop for int I is equal to 0. First legal position in our string. I is less than s dot length. I plus plus, we can finally use it. All right. So now we can ask the question. We only want to display the value if it's not a vowel, right? If it is a vowel, we want to remove it, not display it. So if not is val of s at bucket I. So if s at bucket I is not a vowel, then we want to see out s at bucket I. Then after the for loop, I'll kick it down the line. So now this code will go through our whatever stored in string s and only display the non-vowels. So we should get an HLL out of this guy. There's our HLL. All right, makes some sense? And if you don't go ahead.
So what's with the I plus plus we put there?
Remember we talked about that last class when we had I plus plus is the same thing as saying I is equal to I plus 1. Last class, we talked about the difference between I plus plus, plus plus I minus minus, minus minus I. I think they are.
Right.
Yeah, these guys right here. So now that we've introduced it, I think if you look at 100 programmers code, 99, possibly 100% of them will not say I equals I plus 1. They would say I plus plus or plus plus I. If I say I plus plus or plus plus I in this particular case, does it make any difference? In both situations, I is going to be 1 greater than it used to be, right? Where that plus plus comes in only makes a difference when you're using the value directly. So I'm suggesting just never use that value directly until you've gotten experienced enough to know exactly what you're doing and know what to expect. You'll never run into problems with the plus plus or the minus minus coming before or after if you always have them stand alone and then you use the value on the next line. Okay? So you'll sometimes see people do plus plus I here. I don't know really where that came from. So I mean, 99% of the time you would see that for loop written this way with your counter being I plus plus. Now, one thing I'll throw in here is let's say that you wanted to say I is equal to I plus 2. Maybe we're not incrementing by 1. Well, does that mean I can say I plus 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 plus? Maybe if you make it look fancier. I plus plus and then take plus plus of that. Is that going to work? We can always tell by resolving it ourselves. Let's say I is currently 5. I plus plus will boil down to a 6. Actually, in this case, since the plus plus came after, it'll boil down to a 5. If I take the number 5, 5 is not a variable. 5 is a hard-coded integer. 5 plus plus does not make sense. It would never make sense for me to rewrite that and say 5 is equal to 5 plus 1. That's effectively what I'm saying there. I'm trying to redefine the number 5, not the value of variable holds. All right. So saying something like I plus 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 plus, it's not that that's not allowed. It's that doesn't make sense. If you break it down into what that is actually trying to say, we're actually trying to say, I want to redefine the value of some number to be larger, one bigger than it used to be. But I'm not changing a variable, I'm changing numbers. Okay, and we don't get to do that. They're kind of, those are hard coded in the reality of life. A 5 is always going to be 5. All right. So you lose the ability to do the plus plus or minus minus shortcut if you want to increment or decrement by more than 1. So it's a nice shortcut for doing the +1 or -1, which is a very common thing you use, but it's not necessarily uncommon to increment by 2 or 3 or 5 or whatever. So you'll have to go back to that other syntax. Technically, there's even another syntax. So instead of saying I is equal to I plus 2, I could write that as I plus equals 2. Called a compound operator. So I plus equals 2 is the same thing as saying I is equal to I plus 2. All of this is syntactic sugar. If you don't like all these special cases, you will never be wrong if you write all of your increments and decrements just like that. I is equal to I plus minus whatever you want to do to it. All right. Nobody's going to be impressed or unimpressed if you choose not to use the plus pluses or you choose not to use the plus equal or minus equal or divide equal or any of that stuff. If you want to just keep it simple, by all means. Okay. And I'm not going to test you on those differences. All right. I won't test you on the midterm or anything about the difference between whether plus plus comes before or plus plus comes after. It's interesting. It's something I want you to store away sometime. It's something that over time you're going to end up learning anyways, probably because at some point you'll use it wrong and have a bug that you spend a week looking for until you finally, because people can tell you something a zillion times, but until you've experienced it yourself, it sometimes doesn't stick with you, right? Okay. But it's not an important concept in terms of writing correct code. Keep it simple. Don't try to be fancy. But I think you'll find that I'll write I++ a high majority of the time. Because up to this point, I've had to really think through it as I'm doing it to make sure I say I equals I plus 1. Just so I'm not using something I haven't introduced. All right. So here's some code that we'll go through and we'll say remove the vowels. All right. Now let's change this up a little bit. Let's say that I want to write a function. And by the way, what we're about to do here is not directly the same, but very related to what you're going to have to do for your homework assignment. Okay. So what I want to do here is I want to write a function that takes a string as that takes say a string as a parameter and returns a string that has the original string with all the vowels removed from it. So this guy's going to return a string. Maybe we call it remove vowels. Going to take a string as a parameter. Remember, we have to prototype it, so I'll just copy that header. We'll throw it up top here with a semicolon after it. Now my program knows about it. So this guy is called remove vowels, and his job is to take in this string and return a new string that is this exact string with all the vowels removed. Make sense? All right. So now let me check something real quick. Have we introduced string concatenation yet? We have not. Okay. So let me introduce that real quick. So up to this point, when you see the plus sign, we always just think of that as a math thing, right? Adding, take two numbers, add them together, give you the result. Not rocket science, right? The plus sign has an additional use when it comes to strings. For strings, this is the concatenation operator. So if I take the string hello and I concatenate onto it the string world, I end up with the string hello world. Concatenation glues strings together. If I want a space in there, I can say hello, concatenated with the space, concatenated with world. And then I get a hello space world. All right. And the programming language will know that you mean the plus sign to do concatenation instead of addition when it looks and sees that, oh, both sides of that plus sign are strings, or at least one side of that plus sign is a string. That's definitely how it works in Java. Let me just, before I advertise that to you, say string S is equal to hello. String S2 is equal to S concatenated with, I'm just going to try to do a 5. See out S2. This would definitely work in newer languages. Let's see if it works in here. Yeah, it doesn't. So in C++, in order for this plus operator to be treated as the concatenation operator, both sides need to be of character type. I think it would work if I put the char 5 in there. Oh, it's yelling about something else down here. Here's because I haven't finished writing this yet. Here's that hello 5. So as long as if it's a character or string type, it'll work. If it is a integer, I would actually have to use, what is it? I to S. There's a function for converting a number into a string. Oh, just toString. I think there's an I to C probably would convert it to a character. toString 5, will that do it? So the capital S. Oh, to underscore string. Yeah, there you go. There's our hello 5. So if you have a number like this and you want it to be treated as a string, let's say you're gluing some strings with some numbers together, you're going to have to make that number behave as a string. So the function to pull that off is called to underscore string. Just a quick little conversion thing. Every language has some little function that'll do that. Most of our modern languages, though, Java, C#, it would automatically let you have that 5 over there and it would do the conversion for you. So you wouldn't have to write it. All right. So that is string concatenation. So now we know how to use the plus sign when it comes to working with strings. So now let's get back down to our function here. So we want to write a function called remove vowels that takes a string in as a parameter and returns a new string that is this string with all the vowels removed. Now, the first thing I'll mention is, think of it this way. Instead of us removing vowels, since we're building a brand new string, let's keep non-vowels. All right. And the way we build new strings is we start off with the empty string. So I'll go ahead and put that in a slide. Let me just go ahead and give you that toString function. So that's how you can convert it into a string. So it's in your notes. Oh, empty string. This is how we build brand new strings with concatenation. Very powerful tool. So if I say string S is equal to the empty string, and then I say S is equal to S concatenated with hello, what I end up with is S is hello. Now, typically what we'd end up doing is we would end up saying S concatenated with an H. So now S is equal to the string H. Then we'd say S is equal to S concatenated with an E. So now we'd end up with an S is equal to HE, so on and so forth. We're building the string one character at a time. And that's what we're going to end up doing here in this example. So I am keeping non-vowels. So I have a string S. Remind me, how many characters are in S? S dot length number of characters. Generically, number of characters in S, and S is S dot length number of characters. So I'm going to create a string here. I'm just going to call it answer. We'll start it off as the empty string. I'll write a for loop that goes through every character in my string. Now, each time through, I want to ask the question, should I keep the next character? That is, I only want to keep things that are not vowels. So if S at bucket I, that's the current character we're looking at. If not is val of that guy. So if it's true that the current character we're looking at, S at bucket I, is not a val, then I want to keep it. So I'll say answer is equal to answer concatenated with S at bucket I. If it is a val, I'm just going to skip it. I won't get into this if statement. We'll spin back up. We'll move on to the next character. So as I loop through my string S, I am building up a brand new string called answer, only concatenating on the things that were not vowels. So when I'm done with that for loop, I can then return my final answer. So up here, I could do a cout, remove vowels, hello, and there's my HLL. If I wanted to save that, I can say string, call this guy answer as well, because remember, this answer is a different value than this answer, because this answer lives inside of the scope that is main. This answer lives inside of the scope that is remove vowels. They are different versions of answer. They do not conflict with each other. You can use a different variable name up here, but if you're holding your answer, it kind of makes sense to put that in a variable called answer or similar, right? So don't not do that just because you don't understand that these are in different scopes, that you're not allowed to do that. So let's go ahead and say, here before this, we'll just say string S is equal to world. So we'll throw a string in a variable first. Then we'll say string answer is equal to is val, remove vowels. Remove vowels, and I'll pass it S. And then I'll say cout answer. So I stored a string called S with the value world. I stored in a variable called answer, whatever remove vowels for that string returned. And then I'm outputting that answer. So this should be world with the vowels removed. All right, that makes some sense. All right, so I will put your homework up here after class, but I'll go ahead and verbally tell you what it is. Your homework will be to write a function that takes in a integer, a number. So like, for instance, 35. And it converts that number to its hexadecimal equivalent. So remember the thing we did in class where you would take the number, divide it by 16, record the remainder, record the whole number part. So the same thing we did for converting from decimal to any base. And the trick on this one is you won't just be doing the math, you will also have to convert, like the number 10 becomes an A. Number 11 becomes a B. 12 becomes a C, because remember the legal hextets and hexadecimal values is 0 through 9, A through F. Okay, and the last thing I'll show you here that'll help you do that. Let's say I do C out 5 divided by 2. So 5 divided by 2 is 2 point something, right? But we're going to see here that it gives me a 2, because this is integer division. If I want the remainder, so this is integer division, C out 5 mod 2 is the remainder. Mod operator gives the remainder of integer division, which is a 1. So 5 divided by 2, 2 goes into 5 2 times with a remainder of 1. So those are the pieces you'll need to do this assignment. All right, so go back and review your notes for how to convert a decimal value to a hexadecimal value. Make sure you understand the problem you're trying to solve. And then you're going to go write some functions that do that and then test them from within main. All right. I'll give you this code as a starting point so you have some examples. I'll put it up in Slack, but I'll also put it with the assignment. All right. Questions, comments, concerns, bribes. All right. So I'll put that up here in a few minutes. I will see everybody on Tuesday. Yep, you take care.